In this video segment, we will deal with one of the most important topics of signals, which happens to be periodic and non-periodic. So how do we define a periodic and non-periodic signals? And we shall also take a few problems and solve after we define what they are. So how do we define a periodic signal? Now, a continuous signal x of t is said to be periodic. So you have a continuous signal x of t and it is said to be periodic with period t. With period t, if there is a positive non-zero value t such that x of t plus t equals x of t for all t. So this is for all t. So what does this mean? This essentially means that x of t plus mt is equal to x of t. Now similarly, this is for a continuous signal. So when we talk about a discrete signal, if I consider x of n plus n equals to x of n for all n, then we say that x of n is periodic. Right? So now, given a signal, how do we find the period of that signal? So that is an important question. So we know that 2 pi f equals omega naught or f naught, where f naught happens to be the fundamental frequency. So I can write 2 pi by t naught is equal to omega naught, or omega naught equals 2 pi by t naught. That means I have t naught, which is 2 pi by omega naught. Right? So we find the fundamental time period by using this expression 2 pi by omega naught. So let's take a few examples. It's very easy to find the period of a given signal, whether the signal is x of t or whether the signal is x of n. So we shall take a few examples and then things will be clear. First one, x of t equals cos t plus pi by 4. Right? So first of all, we need to find whether this signal is periodic or aperiodic, and what is the fundamental time period t naught. So whenever we have a signal representation like this, we know that we have cos omega naught t plus phi. So what is omega naught? Omega naught happens to be 1, the coefficient of t, right? So omega naught equals 1. So therefore, what is t naught? 2 pi by omega naught, which is 2 pi. So the fundamental time period is 2 pi. Therefore, the signal is periodic with a fundamental period of 2 pi seconds. So let's take the second problem. We have x of t equals cos pi by 3t plus sine pi by 4t. So here I have x of t, which is the sum of two signals x1 of t plus x2 of t. Right? So in this case, how do I find the fundamental period of x of t, which is a combination of two signals x1 of t and x2 of t? In such a case, I need to find the fundamental period of x1 of t and then find the fundamental period of x2 of t and then find the LCM of the fundamental periods of both. Right? If the ratio of these fundamental periods is a rational number. Now what does this mean? Find the fundamental period of x1 of t, so that is t1. Find the fundamental period of the given signal x2 of t, which is t2. Check if t1 by t2 is a rational number. If yes, then the signal is periodic. Right? So if t1 by t2 ratio is a rational number, then it is periodic, and then we have to find the fundamental period of x of t by considering the LCM of t1 and t2. Alright, so now what is t1? t1 is 2 pi by coefficient of t, which is pi by 3. So pi gets cancelled, so I have 6 here. And what is t2? t2 is nothing but 2 pi by 4. So pi gets cancelled, 4 into 2 is 8. Right? So t1 is 6, t2 is 8. So what is t1 by t2? it is 6 by 8, which is 3 by 4, which is a rational number. So since it is a rational number, we say that x of t is periodic, which is the sum of x1 of t and x2 of t. Now, how do I find the fundamental period of x of t? How do we do that? To find the fundamental period, of x of t, we consider the LCM of 6 and 8, right? So we know how to find the LCM. 6 can be written as 2 into 3 and 8 can be written as 2 into 2 into 2, right? So what is the LCM? The LCM is max of powers of 2, which is 2 power 3 into 3, which is 8 into 3, which is equal to 24, right? So the LCM of 6 comma 8 is 24, right? So therefore the fundamental period is 24 seconds. Fundamental period of x of t is 24 seconds. The third example, x of t equals cos t plus sine root 2t. So again here x of t is the sum of two signals x1 of t plus x2 of t. So find the periods of x1 of t and x2 of t. So what is t1? T1 is 2 pi by omega naught, which is the coefficient of t, which is 1. And t2 equals 2 pi by coefficient of t, which is root 2. So what is t1? T1 is 2 pi. And t2 equals, so 2 can be written as root 2 into pi by root 2. So root 2 gets cancelled. So we have root 2 into pi. Now to check if the given signal x of t is periodic, I have to find the ratio t1 by t2, which is 2 pi by root 2 pi. Pi gets cancelled, and 2 can be written as root 2 into root 2 by root 2. So you have root 2, right? So the ratio t1 by t2 is root 2, which is irrational. So this is of course irrational. So if the ratio is irrational, x of t is non-periodic. So therefore x of t is non-periodic. Very simple. Let's move on to the next one. X of t equals sine square t. So we know that sine square t is equal to 1 minus cos 2t into 1 by 2, right? So this can be written as 1 by 2 minus 1 by 2 cos 2t. Now 1 by 2 of course represents the DC value, right? So I have to consider cos 2t. So what is the fundamental period? T equals 2 pi by the coefficient of t, which is 2. 2 gets cancelled, so you get pi seconds, right? So this signal x of t is periodic with the fundamental period pi seconds. Fifth one, I have x of t which is equal to e power j pi by 2t minus 1. So we have e power j pi by 2t into e power minus j. So again I have omega naught, which is coefficient of t. So here t naught equals 2 pi by 2. Pi gets cancelled, so I have 4 seconds. So this signal x of t is again periodic with a fundamental period of 4 seconds.